Hello everyone. Today we will see about how we can use these two given vector, the resultant. We should have to take this size that represent 4 Newton, let's say 2 centimeter, is equal with 4 Newton. So in this case, we are representing by the given vector by scaling. This one is called scaling. The third one is, and on the second we have something here which says it is side of parallelogram. Yeah. The given vector, these two vectors that given for us is can be represented by the scale. Then we, by projecting both vectors, we can make it the side of our parallelogram. So the projection of this vector is this one. The projection of this vector is this one. So now it is to the step of more simply. The third step says the resultant is diagonal of the parallelogram. Now we have, this is a parallelogram. Now the diagonal from the starting point, this one is the resultant. This is our resultant vector. So by using these three tips, which are more necessary, we can have this the first case, which says 6 Newton due to horizontal 60 degree and 4 Newton due to horizontal to the right. Now, by using parallelogram method, how we can find this resultant vector? So, overall 60 degree for this, and this one is 6 Newton. We put this size here, or this one, then project this vector to make parallelogram. Here we projected, or this vector we projected here. So to find the resultant vectors, the scaling is left here. So for 4 Newton, we calculate 2 centimeter represent 4 Newton. In this case, if 4 Newton is 2 centimeter, 6 Newton is how many centimeter? We can find by crossing. So it becomes 3 centimeter. For resultant to find, we should have to use measurement. This measurement is it can be ruler, it can be other instrument to find the value of resultant vector. So if 4 Newton, by the way, here what we always should have to remember is finding the size and direction of resultant vector. From scaling, after we measure, then by using our own instrument, be ruler or other, we measure this one. Then let's say we get 7.5 Newton. By first consideration, we said 4 Newton represent 2 centimeter. So we can have, if 4 Newton is 2 centimeter, 7.5 centimeter is how much Newton? So 7.5 centimeter times 4 Newton over 2 centimeter. Centimeter by centimeter, we can cancel. This by 2, 1, by 2, 2. So 2 times 7.5 times 2 Newton. So we can have 50 Newton. This will be the answer of our resultant vector. Now, what left? Finding the direction of our resultant. We we get now the size of our resultant. Now, to find the direction, only using instrument, we can have the value of our resultant. It is angle. So by this means, we can have uh, both size and direction for our resultant vector by using parallelogram method. We can have our resultant or given vector. We'll come back. Let us see the second quiz, which asks us finding resultant force by using parallelogram method. These two vectors given for us. So how we can use parallelogram method to find this resultant force? This result. Okay, that's takes place. Okay, let us find first. We should have to join these two vectors, the given vectors. This one. Okay, this one. But let us project this vector by which is parallel with this vector. Okay, to make parallelogram. Okay, for this vector, the parallel one. Okay, this angle is 45 degree. This is 40 pound. This one is 3 pound. Let us draw diagonal. This diagonal is our resultant force, or let us say capital C. This join the first join where two vectors joining each other. Let us call it A. This one B. Let create this one also small c. Okay. Let us say this one is A. This one is B. To simplify our calculation, how we can find the resultant force. That means this diagonal. In the previous cues, on the first cues, we solve only by taking the instrument and depending on the size of our arrow, which represents the given vector, by first scaling, we can find by that means. But here, we will use other method in parallelogram to find the resultant. Okay, here we have two triangles. Let us say this is first triangle, this is second triangle. But let us use the first triangle to find the resultant force. Okay, before that, let us find the angle C. Angle C is equal to this triangle overall measures 180 degree minus these two. Because of this diagonal line bisects this angle into two, here it is 22 point, is also 22.5 degree. This one is also 22.5 degree. The interior angle low is also become 22.5 degree. Now, when we add this angle and this angle, it becomes 45 degree. 45 degree. Therefore, angle C become 135 degree. Okay, this angle measures 135 degree. Now, how we can find this resultant force? Let us consider side angle side cosine rule. side angle, side cosine rule says c square, this c square, or this is f resultant, that means resultant force. C square is equal with a square plus b square minus 2ab cos of 135 degree. Now, to have C or resultant force, let us make it all under root. C square under root equal with under root of a square plus b square minus 2ab cos of 135 degree. Now C become under radical of this. So let us substitute. Here we said A represents 40 pound, B represents 3 pound. Instead of liters, let's substitute the size of force. So A is 40 square plus B 3 square minus 2 into 40 times 3 cos of 135 degree, it becomes minus 0.707. Therefore, C equal with, if we use calculator and we will compute, we will have around 42.1747. Try to put these all numbers, this minus is multiplied by this minus, it becomes plus. Then scaling this 14 is 3. Put under root, we will have this value. Okay, pound. But let us round it. This is the resultant force. C is equal with, when we round it becomes 42 pound. Student, using parallelogram method is simple and easy method for finding any resultant quantity, including resultant force. Thank you. But let us remember what we have seen under this parallelogram method to find any resultant vector. Parallelogram method is, as I have already said, it is simple and easy way to calculate for non-parallel and non-perpendicular two vectors. So it is a very necessary method. In this method, we have seen 3 tips. The first one is for two given vectors, to find by this parallelogram method, we join their starting point of two vectors together. Then by using that vector, we draw the parallelogram. Then by using that parallelogram, we can have diagonal in parallelogram. That diagonal represents the resultant of a given quantity. So by direct measuring or by using other laws in parallelogram method, we can solve any problems that are not parallel or perpendicular vectors. Thank you for following this video. Thank you, but don't forget to subscribe and share for your friends. Thank you.